Hello and welcome to GED Express Screencast. This is under phuketpals, and today's topic would be about GED mathematics, specifically roots and exponents, and this is teacher marking. Now, for today's objectives, you should be able to evaluate numbers in exponential form and evaluate square roots and use the order of operations agreement to simplify numerical expressions. Now, we will have this phrase example. Suppose we have 2 raised to 5. In this case, 5 is the exponent and 2 is our base number. Now, this is an example of an exponential expression, and the base is defined as the number that is repeatedly multiplied. For example, in this case, 2 times 2 times 2 times 2 times 2. And the exponent is a symbol written to the upper right of a base number that indicates how many times to use the base as a factor. Suppose in this case, we need to multiply 2 5 times. Now, for example, we evaluate 2 raised to 5. That will give you 2 times 2 times 2 times 2 times 2. That will be equal to 32. Now, for example, we have 5 2 that is being read as 5 squared. And like, for example, this square, to find the area, that will become 25. For example, 5 cubed, that would become 5 raised to 3. So we have here a cube, so the answer would become 5 times 5 times 5, which is equal to 125. Now, for example, we have here this exponential expression. We have the base, which is 3, and we have the exponent, which is 2. So we need to multiply 3 2 times, like 3 times 3, that will give you 9. Suppose we have here a negative number attached to 3, so that will become negative 3 multiplied to itself. So negative 3 times negative 3, that is 2. That will give you 9. But in this case, we don't have here a parenthesis. That means the negative number is outside the integer, so that will become 3 times 3 positive 9, and just put the negative sign here to denote that the symbol is outside the number. Now in this case, we have a parenthesis, so we are multiplying negative 3 to itself. So negative 3 times negative 3, that will give you positive 9. Now, that's why parentheses are important, because in this case there are no parentheses, so we will have here this answer. So suppose we have 2 raised to 3, so we are multiplying 2 3 times, so 2 times 2 times 2, that will give you 8. Suppose we have here this negative number without a parenthesis, that will become 2 still raised to 3, and that will give you negative 8. Now, if we have a parenthesis here, that is very important, that will make the equation easier to simplify. So the answer would become negative 2 times negative 2, that is positive 4, and multiply it to negative 2, that will give you negative 8. So no difference. And watch for negative numbers raised to an even power. If it's an odd number, the answer usually becomes negative. If it's an even power, that the answer will become positive. That depends if the base is in negative sign. Now, for example, we have here a negative 3 fifths raised to 3. So we are multiplying negative 3 fifths 3 times. So that will become negative 3 fifths times negative 3 fifths times negative 3 fifths. So in this case, the number or the exponent is an odd number, and we have here a negative sign, so the final answer will still be negative since it is an odd number. And we multiply 3 times 3 times 3, that will give you 27, and 5 times 5 times 5, that will give you 125. Now, for example, we will proceed with the next topic, that will be square roots. Now, in this case, this is an example of a radical, and the number that is inside is our radicand. So the square root of 25 is 5. So this is a principal square root. And what are the roots of 25? That would be positive 5 or negative 5, because positive 5 multiplied by positive 5, that will give you 25, and negative 5 times negative 5, that will still give you 25. So for example, we have square root of 16, that will give you 4, and we have square root of 81, and we have a negative sign over here, so we can just simplify here the radicand, that will give you 9, and put the negative sign. Now for example, we have positive and negative square root of 64, that will give you positive and negative 8, or which means 8 times 8, that gives you 64. Now for example, we have negative 25 over here. This is not a real number because this cannot be simplified. There is no square root for this. Now we follow the order of operations in simplifying roots and square roots and radicals, and also exponents. Now, like what was discussed on the previous screencast, you need to follow the PEMDAS. Now in this case, we have here grouping symbols. For example, this 1, 2, 3 plus 4, that is a grouping symbol, and 2 multiplied by negative 3 is not a grouping symbol. Now we always follow left to right. For example, in this case, we have this, like a short review. So we prioritize the one inside the parenthesis, and you will get 35. Same is true with this. So 5 multiplied with the parenthesis, 3, 15 plus 4, that will give you 19. Now in this case, we also follow the same procedure. Same is true with this, since this is just a review. And what if we're going to have a radical over here? So in this case, we just simplify first this one in parentheses. So that will give you this number, which is 18. So in this case, we solve the one on our radicand. So 100 minus 64, that will give you 36. And then after that, you prioritize the one which is in parentheses. But you need to consider first this one which is in division. So that will give you 18 divided by negative 3, that will give you negative 6. Negative 6 multiplied with negative 2, that will give you positive 12. So 6 plus 12, that will give you 18. Now in this case, we have here an absolute value. An absolute value is like a line, a straight line over here, and then a straight line over there. So any number that is on an absolute value will become positive even if it's negative. So in this case, we prioritize the one that is inside. So you will get 2 minus 5, that will give you negative 3, and 14 minus 12, that will give you 12. Now we copy the numbers that is inside. In this case, we have exponents. Now 7 minus 3, because if it's in absolute value, that will become positive 3. And we have here the simplified exponent 6 raised to 2, or 6 times 6, that will give you 36 minus 3 multiplied with 12. So that will give you 7 minus 3, and then 36 minus 36, because 12 times 3 is 36. Now 7 minus 3 is equal to 4, and 36 minus 36 is equal to 0. But 4 cannot be divided by 0. That's why the answer is undefined. Suppose we have here this one, we have here exponents, and we have here square roots. So we solve it. In this case, we solve first the one inside the parenthesis. So 2 plus 1, that will give you 3. And then we proceed with the next step. So 6 minus 3, the one inside the bracket. So the 6 minus 3 is 3. The next after that would become the simplified form of our radicand over here, which is 49. So square root of 49, that is 7. So on this case, we also simplified our exponent. So negative 3 raised to 2, that will give you positive 9. Since this is an even number, the sign here will become positive. So 9 plus 5 bracket 3 minus 7. So we simplify this one. So 5 times 3, that will give you 15, and we will end up with 17. So because 15 plus 9, that will give you 24, minus 7, that will give you 17. Now suppose we have here this one, like we have a fraction over here. So we solve first 3/4 minus 2/3 using this one. We get first the common denominator of these two denominators. So that will be 12 and 12. 12 divided by 4, that is 3, times 3, that will give you 9. 12 divided by 3, that is 4, times 2, that is 8. So the answer would become 9 minus 8 is equal to 1, and then you just copy the denominator. So the answer over here inside the parenthesis is 1 over 12 divided by square root of 9 over 81 minus 16 over 27 divided by 4 over 9. So the square root of our radicand over here is 3 over 9, because 3 times 3, that is 9, and 9 times 9, that is 81. So we will end up having this, but we need to prioritize first this one, which is division. So we go 1 over 12 divided by 3 over 9. So we cross multiply it. The answer would become this one. So we can cancel this out since they are divisible by 3. So you will get 1 times 1, that is 1, and 4 times 1, that is 4. So next we go here. So 16 over 27 divided by 4 over 9, that will give you 16 over 27 times 9 over 4. The reciprocal of 4 over 9 is 9 over 4. Now after that, we will have this one, since 16 is divisible by 4, and this one is divisible by 9. So we will get 9 divided by 9, which is 1, and 4 divided by 4, which is 1. 16 divided by 4, that is 4, and 27 divided by 9 is 3. So you will get 4/3. That's exactly the answer. So you can just copy it down over here. So the answer a while ago is 1/4, so that is in here, and the answer here is 4/3. So if we're going to solve that, the common denominator is still 12. 12 divided by 4, that is 3, times 1, that is still 3. 12 divided by 3, that is 4, times 4, that will give you 16. So 3 minus 16, that is negative 13. Copy the denominator, that is 12. So that is the answer to our expression over here. Now let's try these examples. Now for example, you have negative 6 raised to 2 minus 18 divided by 9 minus 6. Now you simplify using the order of operations and applying the things that you have learned for exponents. So the answer would be, great job, that is 30. How about this one? 2 parenthesis 4 plus 2 raised to 3 closing parenthesis over 6 plus 30 minus parenthesis 2 plus 4 raised to 2. So in this case, the answer is undefined because the denominator is 0. Now, great job everyone, and thank you so much for trying hard, solving the problems, and staying with me. So for the references, that would still be Math Growing Your Preparation for GED 2000 and Nelson Math 2017. If you want to read this in advance, you may. And thank you so much for watching. That will be all. And I'll see you on my next screencast. And since you are here already, you might as well subscribe to our channel or give it a thumbs up if you find it helpful. If you want to connect with us, go to www.phuketpals.org or go to our Facebook page at facebook.com/phuketpals. You can also give us a message if you have inquiries or suggestions for our organization through line, or give us a call at 081-417-0978. Thank you so much and have a great day. Goodbye everyone.